Alright, SinkPAD was kind enough to give me a few more boards, and before we get started I would like to show you. This was one of their conventional 1.3 watt per meter Kelvin MCPCB, and as you see I had some issues with it. I was just practicing before starting to make this video, and well, I wasn't paying attention, and I managed to pull it off once I realized I was still leaving it on the heat. But yeah, I kind of got distracted there. The board, being so slow to dissipate heat, kept going, and I just watched this as this thing started to brown itself and keep going brown and brown until it was burnt. And then, and I'm not entirely sure if you'll be able to see this or not, but I knocked the lens. The lens literally just popped from the heat straight off of the diode. This is a Seoul Semiconductor Z5M, I think. And yeah, it destroyed it, and I'm not too happy that y'all didn't get to see that, because that would have been a really neat little thing to show while it was going off. Anyways, however, as you see, I had no problem using the actual SinkPAD solid aluminum whatsoever. Mounted up, quick, easy, no problems, nice and shiny, nice hot soldered joints, no cold soldered joints anywhere. And I'm going to demonstrate just how easy this works, and talk a little bit about some of the advantages that I've noted pretty much versus your traditional MCPCB using thermal dielectric. Alright, let's go on ahead and let's start with this X lamp that I've got right here. This is using an older model SinkPAD board, but they still handed it to me saying this would be a really good demonstration. So what I'm going to do is I'm going to demonstrate how quick and easy this is to rework. And I'm just going to turn this on to 1200 watts. Put that in my pliers. So say I'm doing prototype work. I'm doing engineering stuff for my company. I want to do some prototyping work. Well, it turns out I misflowed the diode, and I made a solder bridge of some sorts. So just give this just a few seconds. This heats up relatively quickly, and it will pop right off like it's nothing. Very nice, very clean, no issues whatsoever. That's a very, very quick and easy to rework surface right there. And as you notice, as I pulled it away, any solder bridges that may have been there, solder resistor showing that it's gone, solder resistor showing that it's gone. I could just wipe the little extra solder off of here, pop the board back on if I really wanted to. Set it back up here really quick. Give it just another couple of seconds to reflow and drop. Pull it back. Wait just another couple of seconds. We'll just turn this off while we wait. Alright. This being an X lamp, 3.2 to 3.7 volts, which I happen to have right here. And a positive side and a negative side. Let's turn this back down so that you can actually see this. Here we go. And boom. Perfect. Lights right up. Let's turn that around so that you could actually see that. Boom. Quick, easy, reworkable, very, very fast to fix a mistake that you might have made. I noticed with the dielectric, it was a little bit harder to actually pull it off. It took a little bit longer underneath the heat gun in order for me to get the solder to reflow without using, say, flux. And that's what I'm basing this little test on, is without using flux. The SinkPAD gets hotter faster, cools down faster, so you can get it up to heat really fast, get the solder joint set and ready to go, and then pull it right away, and it's cooled off very, very quickly. Like even this one, sitting underneath 1200 watts, I can pick it up. It's barely even warm, not a problem. And it's been so easy. Hand soldering of MKRs, not a problem. And then once again the Z5, which was not a problem there either. I happen to also have noticed since this was designed for the Nichia N219, which is basically just the thermal version, the thermally neutral version of the 119 diode, I figured I would try popping the 119 on there. And it turns out that if you just tin the leads and then put something non-conductive like a thermal-conductive paste or something on the center pad, this will actually accept a 119 diode, which only has 2 contacts. And I was actually surprised and pleased about that. So while it does take a little modification, those that are into it could easily rework this particular board to be a lot better and use other different diodes. And I checked it out, it worked just fine. And the fun part is, the diode that I used on it, this 119 here, actually, originally I hit it with a hammer. I was testing how tough the packaging material was. And I hit it with a hammer, and I can apply current to it right now, and it will still light up. This was an incredibly tough diode. Anyways, back to the SinkPAD. It's really, really simple. I actually like how easy that these will take solder. So let's say, like, I'll take this SinkPAD right here. This is another one of the XPG, XPE, XPC, the Nichia N219, Samsung 3535, and this actually works for the Z5 from Seal Semiconductor. And what I'm going to do is let me get my solder here. And because it's aluminum, it actually heats up locally very, very quickly, so it makes taking solder a breeze. So like, I'll just set this right here, and the solder's on. That's a lot quicker than trying to do it on the dielectric. After about 5 seconds, that's heated up. Let's take our typical dielectric. These are always marked with the red marker. I made sure to make that distinction. That's a little tiny pad too. Let's see if I can't actually get that to go really fast. 1, 2, 3, 4, 5, 6. Come on, take it. 7, 8. Take it. 9, 10. Come on. I know you want to take. There it goes. Okay. Finally. And oh, that's kind of crappy. They should have just taken it. Notice I actually fed that almost down to getting my fingers burnt, and it just took forever to get itself soldered up. I'm not too enthused about that, and I'm glad I don't have to mount anything else on there. In fact, I'm probably not going to even use these at all. Oh, I might, it just depends. But I think I'm personally going to stick with the SinkPAD. And yeah, the SinkPAD by far is superior. Let's do a little bit of other stuff here. Maybe we can, oh okay, I know what we can do. We're going to run various drive currents through this. And the fun part is I'm going to throw an MKR onto this. And let's just take this one right here. And a little thermal goop. And sink that on there. Press it down nice and tight. Alright. And let's see, I'm going to pop 12 volts through that, but I wonder how much I'm going to want to push. I think I'm going to run, well, this is a 15 watt diode. 12 volts at 1.25 amps. I think I'm going to push this to 36 watts just to see if the SinkPAD and this heatsink, without the fan being attached, will take. So give me a second here. And the only thing I need to do is just get the power supply taken off my aquarium here so that I can get everything set to go for you. And this is a 12 volt at 3 amp power supply, and it pushes it straight on as soon as it clamps down. Alright, and let me desolder this really quickly. One and two. Alright. Let me clean off the leads on this for just a second, because this is not very nice looking. I mean, it'll do the trick, but I don't like that. Other neat things that I think I like about the SinkPAD is the dielectric actually seems a little heavier versus SinkPAD. Dielectric, in fact, seems to be about It seems to be about maybe 20% heavier versus the SinkPAD of the same size. Something like that. I know it has a little bit more heft. It's got a more solid thud when I dropped it on the floor earlier. Alright, I'm just going to pick up some of the stray solder that's sitting on this brass table here and make a quick connection. Alright, positive. It doesn't have to be the best connection on the planet, it just has to stick for this demonstration. And not go everywhere like I just about did there. Alright, we're set to go. And just in case you're wondering, this is, and it says it right here, 12 volts at 3 amps, 36 watts. This is from Yamaha. This is from an old external CD drive with a burner and laser scribe system on the top of it. Alright, let's plug this in, and we're just going to sit here and see how well the SinkPAD will take 36 watts. Will it keep the MKR cool enough? Did I even get the soldering joint on there right? That could be a problem. Did I reverse them? No. It's set. It's on there. And I'm wondering if I killed my power supply when I was pulling it out. Oh well. That's not boding very well, because now how am I going to light my fish tank? Let's see if I just can't do this a little bit better. These are solid. I should be getting a solid connection here. This should actually be working. Oh, you know what? It's probably not because I don't have the fan attached. It needs a resistive load to start. Oh, that's kind of a dirt moment for me there. Let me look. Does it need it? Oh yeah, it needs it. Well, alright, we'll just use a different driver then. I've got a 2 amp driver that I can use. Let's take this off, and I'm going to have to redo the thermal paste now. But I'm going to bet you money this SinkPAD will work very, very, very well with this. Alright, more thermal goop. And feel free to cut and edit out any of this video that you want. Download a copy of it. I'll give you a copy if you want, so you can, you know, change it up or whatnot. Sit and stay. Okay. I'll actually slide down just a little bit further because I need to be able to make the connections, which I still can't. Wow, it apparently is not going to let me get that done, so let's just do a regular old demonstration and see how well it'll work passively. Let's take my... what's that? That's 5 volts. Alright, here we go. This one is 12 volts at 1.5 amps, so we'll actually just overdrive it the tiniest bit and we'll not do it too much. Come on, go. Alright. Boy, this is getting ugly looking. Well, I'm not the world's best solderer, that's for sure. It's not really important though. What's important is making sure that this diode is actually functioning now that it's on the SinkPAD. And for some reason I'm not getting anything, which means I might have damaged that diode. Well, that would be my fault, not the fault of SinkPAD. That's for sure. Alright. Let's go on ahead and just take this off then. Anyways, wow, working with the SinkPAD is pretty easy. But unfortunately, I may have just destroyed something yet again, hence why I'm called the LED Punisher. Well, anyways, I'm not going to bore you with trying to rework this, and I'm just going to cut the video short here, but anyways, the SinkPAD definitely has a lot of advantages. The advantages I've noted: faster, easier rework, heats up faster, cools down faster. You could definitely increase prototyping and production times using SinkPAD's aluminum technology. And I seriously would love to see more of this stuff either in copper or maybe an aluminum carbon composite, or maybe if we can get over carbon's little special snowflake heat distribution, then we could actually use just carbon pads, and that would be awesome. Anyways, y'all have a good one. Thanks for watching me destroy something yet again. Later.